TV, mag-aral ng maigi to get the lessons easily. It's tangkop, tangkop, tangkop time. We learn all things, it's very fine, masaya. Tutok na. It's tangkop, tangkop, tangkop time. We learn all things, it's very fine, masaya. Tutok na. Tayo na. Let's come and learn together, supporting one another. We love, we care, we share. It's tangkop, tangkop, tangkop time. We learn all things, it's very fine, masaya. Tutok na. It's tangkop, tangkop, tangkop time. We learn all things, it's very fine, masaya. Tutok na. It's tangkop, tangkop, tangkop time. We learn all things, it's very fine, masaya. Tutok na. It's tangkop, tangkop, tangkop time. We learn all things, it's very fine, masaya. Tutok na.
Good morning to our senior high school learners who are watching via FB Live at DepEd Tanggub, and
Astral Academy Cyber School.
I am Sir Jefferson Gabutan, a teacher from Pangabuan Integrated School.
And I am Sir Kenneth Perez from Banglay National High School.
And I am Sir Vincent Bondibon from Tanggub City National High School.
And we are your teacher facilitators for today. Good morning mga sir.
Good morning, Sir Jeff.
So today is March 2, 2022, and we will be discussing topics about computation of the variance of a discrete random variable.
That's right, Sir Jeff. And we will discuss on how to compute the variance of a discrete random variable.
Okay, so
Stay tuned, learners, because we will be right back after a short break. This is
Astral Academy Cyber School.
And we are back, still here in Astral Academy Cyber School.
Okay, so last time we had discussed on how to compute the mean of a random variable. So this time, sir, let us proceed on how to compute the variance of a discrete random variable.
Yes, that's right. And the variance of a random variable x is denoted by sigma squared. And it can likewise be written as the var of x. So the variance of a random variable is the expected value of the square of the difference between the assumed value of the random variable and the mean. And then the variance of x is given by the formula sigma squared is equal to the summation of the quantity of x minus the mean squared times the p of x, or the probability of x, where x is the outcome and mu is the population mean and P of x is the probability of the outcome.
Okay, so now there are steps, sir, on how to compute the variance of discrete random variable. So the first step is to find the expected value or the mean. So ato siyang discuss last time, sir. Then the second step is to subtract the expected value of the mean from each outcome square and square each difference. And then the third one is to multiply each difference by the corresponding probability. And then the last step is to sum up all the figures obtained in step 3.
Okay, so they have to follow the 4 steps. Okay, let us have an example. This is the same, different example from the last one. First, we have determine the variance of the following probability mass function, where our x are 0, 1, and 2, and their corresponding probabilities are 0.25, 0.5, and 0.25. Take note that the sum of the probabilities is equal to 1. Okay, so for the solution, we have, or we're going to make 6 columns, right, Sir Jeff?
Yes, that's right, Sir
Okay,
Kenneth.
so first column we have x. The value of x are 0, 1, and 2. And then the second column we have p of x. Then write the corresponding probabilities. 0.25, 0.5, and then 0.25. And then next, in the third column, you are going to multiply all the values in the first column to the second column. So 0 times 0.25 is 0. And then 1 times 0.5 is 0.5. And then 2 times 0.25 is 0.50. Okay, next, you are going to find the mean.
The mean.
Yes, or the expected value. The mean is just the sum of x times p of x. So 0 plus 0.5 plus 0.5 is equal to 1. Okay, so the mean or the mu now is 1. So for the fourth column, you subtract the value of x minus the mean.
Yes, sir.
Right? So 0 minus 1 is equal to negative 1. 1 minus 1 for the second is 0. Then 2 minus 1 is equal to 1. Next step is for the fifth column. We're going to square the result in the fourth column.
Yes.
So negative 1 squared is positive 1. 0 squared is 0. And then 1 squared is 1. And then lastly, for the sixth column, you're going to multiply the result to the value in the second column, right?
Yes,
Or
which
the
is
probability.
Or the
of
probability of x. So 0.25 times 1 is 0.25. Then 0.5 times 0 is 0. And 0.25 times 1 is 0.25. And then take the sum. The sum is the variance. So 0.25 plus 0 plus 0.25, and the result is 0.50. So therefore, the variance of the discrete random variable is 0.50.
Yes, that's right, Sir Kenneth. Now, let us have another example for our learners to understand much better. So, for the example number 2, we are to determine the variance of the following probability mass function. So given...
That example is given in the last week.
Yes, the previous week that we have discussed. So we have our x, we have 0, 1, 2, 3, and 4. And for its corresponding probability, we have 0.1, 0.2, 0.3, 0.3, and 0.1. Remember, students, that we are to follow the 4 steps in order for us to get the variance of the discrete random variable. So, first is let us make a table for our to be organized. So we have in our first column the x, so 0, 1, 2, 3, and 4. For the second column, we have the probability, which are the 0.1, 0.2, 0.3, 0.3, and 0.1. At the third column, we are to multiply the x and the probability of x. So 0.0.1 is 0, 1 times 0.2 is 0.2, then the next 0.6, 0.9, and then 0.4. Now, the next step is to get the
sum.
Mean.
Yes, the mean. So,
The mean.
so the summation of the x times the probability of x is equal to 2.1.
And that is the mean of the
Yes,
discrete
that is
random
the mean.
variable.
So we are to use that in the fourth column. So for the fourth column, we are to subtract the x minus the mean. So for our x, we have 0 minus the mean 2.1 equals negative 2.1. 1 minus 2.1 is negative 1.1. And then the rest will follow negative 0.1, 0.9, and 1.9. So what are the next column, Sir Vincent?
Okay, so in the next column, so we will we will square the result in the fourth column. So we will square the difference between the value of the random variable and the mean. So we have, for example, sir, we have the square of negative 2.1, that is equal to 4.41. The square of negative 1.1, that is 1.21. So negative 0.1 square, that is equal to 0.01. 0.9 square, that is equal to 0.81. And 1.9 square, that is equal to 3.61. Then, the last column, sir, Ken?
Okay, for the last column, you multiply the result in the fifth column and the probability of x, or the values in the second column. So multiply 0.1 to 4.41. The result is 0.441. 0.2 times 1.21 is 0.242, and then do the rest up to 0.1 times 3.61, and the result is 0.361. Then you add all the results in the sixth column. So 0.441 plus 0.242 plus 0.003 plus 0.243 plus 0.361. The result is 1.29.
So therefore, the variance of the discrete random variable is 1.29. So
that's it, and that is the topic on how to compute the variance of the discrete random variable.
Okay, so stay tuned, learners, because we will be right back after a short break.
this is Astral Academy Cyber School.
Sa duha tulo, upat lima unom, ang mati ay sayon. Sa duha tulo, upat lima unom, ang mati ay sayon. Addition o multiplication, subtraction o ang division. Problema dali ra sulbaron, kay ang mati ay sayon. Sa duha tulo, upat lima unom, ang mati ay sayon. Sa duha tulo, upat lima unom, ang mati ay sayon. Ang mati ay sayon. Ang mati ay sayon.
And we are back, still here in
Astral Academy Cyber School.
So this time we will have our discussion for basic calculus.
Okay, Sir Jeff, so our topic today is still about the limit theorems.
Exactly, Sir Ken. So last time, we already discussed the first four limit theorems. So we have the limit of a constant is itself, the limit of x or identity as x approaches to c is equal to c,
The constant multiple theorem, and the addition theorem, which states that the limit of a sum of functions is the sum of all the limits of the individual functions.
Okay, so those are the first four limits. So now let us proceed to the remaining limit theorem. So the next limit theorem is known as the multiplication theorem. This theorem is similar to the addition theorem, which multiplication replacing addition as the operation involved. Thus, the limit of a product of functions is equal to their product of their limits. So, the limit of f of x times g of x as x approaches to c is equal to the limit of f of x as x approaches to c times the limit of g of x as x approaches to c. That is equal to L times m. Again, if the limit of f of x as x approaches to c is equal to 4, and then the limit of g of x as x approaches to c is equal to negative 5, then the limit of f of x times g of x as x approaches to c is equal to the limit of f of x as x approaches to c times the limit of g of x as x approaches to c. That is equal to 4 times negative 5. And that is equal to negative 20.
20. Yes, sir. So, but we would like to inform our learners, sir, that the addition and multiplication theorems may be applied to sums, differences, and products of more than two functions.
That's right. Additionally, the constant multiple theorem is a special case of the multiplication theorem. Indeed, in the multiplication theorem, if the first function f of x is replaced by a constant k, the result is the constant multiple theorem.
Okay, so let us have the next theorem, which is the division
theorem.
theorem. So this says that the limit of a quotient of functions is equal to the quotient of the limits of the individual functions, provided that the denominator or the limit is not equal to 0. Why? Because it is undefined.
So we cannot define division by
Yes.
0.
The limit of f of x divided by g of x as x approaches to c is equal to the limit of f of x as x approaches to c all over the limit of g of x as x approaches to c. Then that is equal to L over m, provided that m is not equal to 0, and that is the limit of g of x.
Exactly, Sir Ken. Now, let us have an example. Given that the limit of f of x as x approaches to c is equal to 4, and then the limit of g of x as x approaches to c is equal to negative 5, let us use the formula limit of the f of x over g of x as x approaches to c. That is limit of f of x as x approaches to c over limit of g of x as x approaches to c. Substitute the value. We have 4 over negative 5, and then to simplify, we have negative 4.5.
Okay, sir. So let us have another example, sir. So if the limit of f of x is equal to 0, and then the limit of g of x as x approaches to c is equal to negative 5, so using the same formula, so we have the limit of f of x over g of x as x approaches to c is equal to the limit of f of x as x approaches to c over the limit of g of x as x approaches to c, and then given that the limit of fx is 0 and the limit of g of x is negative 5, so we have 0 over negative 5, then simplify, then we have that is equal to 0.
However, for another example, if the limit of f of x is equal to 4 and the limit of g of x is equal to 0, it is not possible to evaluate the limit of f of x divided by g of x. For we say that the limit b and a or
Does
not exist.
Yes. So that is right, sir Ken. So the next theorem, sir, is known as the power theorem. So this theorem states that the limit of an integer power p of a function is just the power of the limit of the function. So if the limit of f of x as x approaches to c is equal to L, then the limit of f of x raised to the power of p as x approaches to c is equal to the limit of f of x as x approaches to c to the power of P. That is equal to L raised to P.
Power.
P. So for example, if we have the limit of f of x as x approaches to c is equal to 4, then if we have a limit of f of x raised to the power of 3 as x approaches to c, that is equal to the limit of f of x as x approaches to c to the power of 3. That is equal to 4 to the power of 3, and then simplify, and that is equal to 64.
That's right, Sir Vince. So let us have another example. Say for example, the limit of f of x as x approaches to c is equal to 4. Then we have the limit of f of x as limit of f of x
To the
raised
power
to the
of
negative 2 as x approaches to c is equal to the limit of f of x raised to the negative 2 as x approaches to c. So let's we have the given value. We have 4. So 4 raised to the negative 2 is equal to 1 over 4 of 4 squared. So we are to eradicate the negative sign. So ato siyang butang sa denominator to eradicate the negative sign sa power. So we have 1 over 4 squared, or that is equal to 1 over 16.
Okay, and the last limit theorem is the radical or the root theorem. This theorem states that if n is a positive integer, the limit of the nth root of a function is just the nth root of the limit of the function, provided the nth root of the limit is a
Real number.
Thus, it is important to keep in mind that if n is even, then the limit of the function must be positive. So if the limit of f of x as x approaches to c is equal to L, then if the limit of the square root of f of x as x approaches, that is not the square root, it's nth root, as x approaches to c is equal to the nth root of the whole quantity of the limit of f of x as x approaches to c. And that is just equal to the nth root of L. So for example, if the limit of f of x as x approaches to c is equal to 4, then the limit of the square root of f of x as x approaches to c is equal to the square root of the limit of f of x as x approaches to c. And that is the square root of 4, and the square root of 4 is 2.
Equal to.
Yes, that's right, Sir Kenneth. Now let's have another example. Now if the limit of f of x is equal to negative 4, now then it's not possible to evaluate the limit of the square root of f of x as x approaches to c, because then if we are to write it down, so the square root of the limit of f of x as x approaches to c, that is the square root of negative 4, and that is not a real number. So we have our limit theorems now. So pila to ka limit theorems
There
na
are 8 theorems na itong na-discuss, sir.
Yes, that's right. So learners, those are the limit theorems that can be used to determine the limit of a function.
So learners, based on the things that you have learned today, kindly answer the activity sheets found in your self-learning materials.
So before we end, learners, don't forget the first attendance marker, and special thanks to our executive producer, Sir Gas Sipe, to our production team, and to our learners who are very eager to learn despite of this no face-to-face. But we are praying, no? And we are hoping for the face-to-face later on. So this has been Sir Jefferson Gabutan from Pangaban Integrated School.
And Sir Kenneth Perez from Banglay National High School.
And Vincent Esponabon from Tangub City National High School.
And this is Astral Academy Cyber School.